when a body moves in a circular path at a constant speed, it is said to be in uniform circular motion. As the body is continuously changing its direction of motion, its velocity changes continuously. Since the velocity of the body is changing, it has acceleration, which is known as centripetal acceleration. Let us find the magnitude and direction of the centripetal acceleration. Here, r and r' are the position vectors, and v and v' are the velocities of the body at points P and P'. As the body is moving in the circular path, the velocity vectors will be tangential to the circle at the points P and P'. The change in velocity, delta v, is obtained by using the triangle law of vector addition. V and r, as well as v' and r' are perpendicular to each other as v and v' are tangential to the circle, and r and r' are the radii of the circle. Therefore, delta v is perpendicular to delta r. If we place delta v along the line which bisects the angle between r and r', the arrow of delta v points towards the center of the circle O. The average acceleration acts along delta v. Therefore, average acceleration E bar is directed towards the center of the circle. We can verify all these by changing the position of the point P'. As delta t tends to 0, the angle delta theta also tends to 0, and hence the average acceleration becomes instant acceleration. Therefore, we can conclude that the acceleration of a body in uniform circular motion is always directed towards the center of the circle. Now let us find the magnitude of the acceleration. As you know, the angle between r and r' is delta theta. As v and v' are perpendicular to r and r', the angle between v and v' is also delta theta. Therefore, triangle OPP' formed by the position vectors and triangle ABC formed by the velocity vectors are similar. From these similar triangles, we can write magnitude of delta V by V is equal to magnitude of delta R by R, where R is the radius of the circle. This can be written as magnitude of delta V is equal to V into magnitude of delta R by R. Magnitude of A is equal to limit delta t approaches to 0. Magnitude of delta V by delta t, which is equal to limit delta t approaches to 0. V into magnitude of delta R by R delta t. This expression can be written as magnitude of A is equal to V by R into limit delta t approaches to 0, magnitude of delta R by delta t. Let this be equation 1. As delta t approaches 0, delta theta also approaches 0. Arc PP' is approximately equal to PP' which is equal to magnitude of delta r. Magnitude of delta r is approximately equal to V delta t. This can be written as magnitude of delta r by delta t is approximately equal to V, which implies limit delta t approaches zero, magnitude of delta r by delta t is equal to V. Let this be equation 2. Substituting equation 2 in 1 and by simplifying, we get A is equal to V square by r. Let this be equation 3. The acceleration of a body moving with a constant speed v in a circle of radius r has a magnitude v square by r, and it always acts radially directed towards the center of the circle. This acceleration is called centripetal acceleration. The word centripetal refers to center seeking. Now, let us find the centripetal acceleration in terms of angular velocity, omega. As the body moves from P to P' in time delta t, the line OP turns through an angle delta theta. As you know, omega is equal to delta theta by delta t. Let this be equation 4. V is equal to arc length PP' by delta t, which is equal to delta S by delta t. Let this be equation 5. Delta S is the arc length, which is r delta theta. Let this be equation 6. Substituting 6 in 5, we get V is equal to r delta theta by delta t. Let this be equation 7. Substituting 4 in 7, we get V is equal to r omega. Let this be equation 8. Now, substituting equation 3 in 8, we get centripetal acceleration AC is equal to omega square into r. Now let us find the centripetal acceleration in terms of frequency. Time taken to make one revolution, that is, time period is t. Frequency, f, is the number of revolutions in 1 second. Therefore, f is equal to 1 by t. Distance moved by the body in one revolution is equal to 2 pi r. V is equal to 2 pi r by t. On substitution, we get V is equal to 2 pi rf. Omega is equal to 2 pi f. Substituting the values in equation 3, we get AC is equal to 4 pi square f square into r.